Alright guys, so in this video we are going to learn about reflections and inverses. So reflections in the line y equals x. So all inverses are a result of reflecting across the line y equals x. Okay? So basically all you have to do is interchange the x and the y. All right, if y is equal to x, then if you swap them out, that'll give you, and then you solve for y, that'll give you the reflected image across the line y equals x. All right, this green line, of course, is the line y equals x. This blue line would be y equals e to the x. And then this red line would be x equals e to the y. However, your calculator would not be able to graph that, so what you'd have to end up doing is taking the natural log of both sides, then using a power property of logarithms where you drop the y out front. So ln x equals y times ln e. And then you'd have to recognize that ln times, or the natural log of e, they actually have the same base. So this is actually going to be 1. This is just something that we're going to come to understand. Okay, so that cancels out to be 1. So this graph is the same thing as y equals ln x. Right? I'm probably talking too much there. Okay, so inverses. So to create an inverse of some function, replace f with the letter y, then change out the x and y in order for the new graph to be a function of the original graph. It must satisfy both the horizontal and vertical line tests. All right, we call that new function f inverse. Okay, so we don't call it f to the negative 1 power, we just call it f inverse. So in this case, what if I said sine and then I wrote it like this? What is a good name for this one? Inverse sine or sine inverse. All right, sine inverse. How about this one? Cosine inverse. Perfect. All right, so anytime we get this little negative 1 power and it's on top of a function, we're going to call it inverse. Okay, now if we have an independent variable like x, we don't typically call that x inverse. We typically just rewrite it as 1 over x to the first power. Okay, so the notation kind of overlaps a little bit, but not really. Okay, so it does say to the negative 1 power, but we're talking specifically when we raise a function to a negative 1 power, we call that the inverse. All right, so if I have f equals 4x minus 7, then that's the same thing as y equals 4x minus 7. And then what we'll do is we'll switch and just say that x equals 4y minus 7. All right, and then we undo this thing using algebra. We're going to add 7 and then divide 4. Okay? You can go ahead, you can probably get to the answer before I can. I'm going to write all the steps out because one year when I didn't write all the steps out and the algebra got a little bit more challenging, students were unable to actually do the problems. Okay, so the answer is y equals x plus 7 over 4, and if we want to call it f inverse of x. Okay, so maybe I'll just mark that out and say that it's f inverse of x, just to save a little bit of pencil space here. All right, so the second problem, we'll say y equals 2x to the third minus 5. We'll switch out the x and y. We're going to add 5 and then divide by 2. Okay? X plus 5 equals 2y to the third power. Divide by 2 gives me y to the third power equals x plus 5 all over 2. Okay, we still need to get rid of this third power. So the way we get rid of a third power is we can think we need to raise it to the 1/3 power. If you raise something to the 1/3 power, do you see how the exponents would multiply to equal 1? So now it's going to be y to the first power, right? So I'm going to raise both sides to the 1/3 power. Yeah, that's a great question. Somebody's asked, why don't I just cube root it? And actually the answer is that is the same thing as what I'm doing. So radicals and fractional exponents are equivalent. Yep. Actually, as a final answer, that's what I was going to write. I was going to write it. So from there, yes, ma'am? Oxymoron. That's the word. Yep. Oxymoron. Microsoft works. Yeah. Okay. Here we go. Y to the third raised to the 1/3 would just be y. So we're going to say that y equals, and if all of this is raised to the 1/3, we could also rewrite it as the cubic root of all of this. So that can be your final answer. You can write it as f inverse of x equals the cubic root of all of this stuff. So in that question, I'm just showing you how you can use fractional exponents, and fractional exponents are the same thing as these radicals sometimes, okay? All right, so on the last question, won't you pause for a minute, try to see what you remember about the natural log of x. Okay, so I've written a couple lines so far. Then we're going to, we need to get y by itself. And the way that I typically show that is that I typically will create a base and call the x exponent. So I'll call it e to the x equals e to the natural log of y. Actually, this is a little bit different than what I did before, isn't it? So now if I have e to the x and I have e to the ln y, what we're going to have to start memorizing is that e to the ln, ln of whatever that is just going to cancel out to give you y. Okay, so this would be y equals e to the x. In other words, f inverse of x equals e to the x. All right. I was wondering, should there be some kind of domain restriction? Maybe not. Okay, so an important fact to note about inverses is that we do the opposite operations in the opposite orders. So in example 2, the number is cubed, then it's multiplied by 2, then it's subtracted by 5, or 5 is subtracted. So then what we need to do is the opposite of that. So so 5 is added, then it's divided by 2, and then it's raised to the 1/3 power, or the cube root is taken. All right, here's another point, is that if you compose the two functions and you get x, and you compose it in two different ways and you get x, then those are called inverse functions. Okay. All right, that's all for this lesson. Why don't you take a look at those homework exercises and then call it a day.